There's a planet in our solar system where you can never land, because there is no ground. If you tried, you wouldn't crash. You would sink through freezing clouds, into winds faster than sound, into pressure so violent it would crush a spacecraft long before it reached anything solid. And the worst part, it's so far away that once you fall, being rescued feels like a fantasy. This is Neptune, and it's not the blue paradise people imagine. It's an abyss. Welcome to Simulation Hypothesis, where we don't just look at planets, we step into them. If you're new here and you like space explained without the sugarcoating, subscribe. Because today, we're not admiring Neptune from a distance. We're falling into it. Neptune looks calm in pictures, a smooth blue sphere, clean, minimal, almost peaceful. If Earth is chaotic and Jupiter is violent, Neptune seems distant and elegant, like the quiet one at the edge of the solar system. That illusion lasts exactly until you look at the data. Neptune is not a place you land on. It's a place you descend into and never reach the bottom. Let's start with the first problem. There is no surface. Neptune is classified as an ice giant, but that phrase is misleading. There isn't a frozen crust waiting beneath the clouds. There isn't rock under a thin atmosphere like Mars. Neptune is layered atmosphere blending into fluid blending into exotic high-pressure states of matter. The deeper you go, the less familiar physics becomes. If a human spacecraft tried to land, it would first hit the upper atmosphere, thin, cold, and deceptively quiet. But even there, Neptune begins to show its hostility. The average temperature at the cloud tops is around -214 degrees Celsius. That's colder than liquid nitrogen. Any exposed material becomes brittle, lubricants freeze, electronics struggle, and this is just the beginning. Because Neptune doesn't just sit in the dark. It moves violently within it. Voyager 2, the only spacecraft ever to fly past Neptune in 1989, measured wind speeds exceeding 2,100 kilometers per hour. That's faster than the speed of sound on Earth. These are the fastest sustained winds measured anywhere in the solar system. Think about that for a second. Neptune receives only about 1/900th of the sunlight Earth does. It sits 4.5 billion kilometers from the sun. By basic logic, it should be frozen and still. Instead, it has supersonic storms. Where does that energy come from? That's part of what makes Neptune terrifying. It radiates more energy than it receives from the sun. Neptune generates internal heat. Something inside that planet is driving motion powerful enough to whip an atmosphere into sonic violence, in near darkness. As you descend deeper into Neptune's clouds, visibility drops. Methane in the upper atmosphere absorbs red light, which is why Neptune appears blue. But that blue isn't an ocean. It's a chemical filter over chaos. Below the upper haze layers are thick cloud decks of methane ice, ammonia, and hydrogen sulfide. Storm systems form and dissipate. Dark spots, massive atmospheric vortices larger than Earth, appear and vanish over years. One of these storms, discovered by Voyager 2, was called the Great Dark Spot. It was roughly the size of our planet. By the time Hubble looked again years later, it was gone. Neptune's storms don't linger politely like Jupiter's Great Red Spot. They form, they rage, they collapse. Unpredictable. The deeper you fall, the pressure rises quickly. Within a few thousand kilometers, the atmosphere thickens dramatically. Hydrogen and helium dominate, but under increasing pressure they behave less like gas and more like fluid. This is where Neptune stops feeling like a planet and starts feeling like an ocean you can't swim in. Because there is no clear boundary between atmosphere and interior, there's no splash, no impact, just increasing density. Your spacecraft would experience growing external pressure, crushing, compressing, stressing every seam. Communication delays back to Earth are already over 4 hours one way. There is no real-time control. By the time mission control hears a problem, it's history. But the real horror is not the atmosphere. It's the distance. Neptune is so far from Earth that rescue is a fantasy. At its closest, Neptune is about 4.3 billion kilometers away. At its farthest, nearly 4.7 billion. Even traveling at tens of thousands of kilometers per hour, it takes spacecraft over a decade to reach it. Voyager 2 took 12 years. If something goes wrong near Neptune, you are alone in a way that humans have never experienced. Mars is months away, the Moon is days away, Neptune is years. And that isolation changes everything. Because in deep space, time becomes the enemy. Now imagine the descent continuing. As pressure increases, temperatures rise again. This is another counterintuitive reality. Despite the freezing upper layers, deeper regions of Neptune are extremely hot, thousands of degrees Celsius. Models estimate core temperatures comparable to the surface of the Sun. This isn't a contradiction, it's compression. Gravitational pressure generates heat. The deeper you go, the more the planet squeezes itself. And then physics becomes strange. Under immense pressure, water, ammonia, and methane, the ices in Ice Giant do not behave as they do on Earth. They form exotic phases. Superionic water may exist there, a state where oxygen atoms form a lattice and hydrogen ions move freely, creating conductive layers. Some scientists propose that this strange conductive layer is responsible for Neptune's bizarre magnetic field. And Neptune's magnetic field is bizarre. Unlike Earth's relatively centered, stable magnetic field, Neptune's is tilted about 47 degrees from its rotational axis and offset from the planet's center. That means the magnetic environment is asymmetric and dynamic. Radiation belts form unpredictably. Charged particles are accelerated erratically. If you were orbiting Neptune, radiation exposure would not be trivial. And yet, that's still not the deepest part. As you descend further, if your craft somehow survived, the hydrogen and helium transition into dense fluid layers. The distinction between atmosphere and ocean vanishes completely. You are not falling through air anymore. You are sinking through a conductive, pressurized fluid. Eventually, the pressure would exceed millions of times Earth's atmospheric pressure. No known material could withstand that indefinitely. There is no solid ground to brace against, only deeper layers of increasing density, temperature, and stress. Neptune doesn't kill you with a single dramatic moment. It erases you gradually. And that gradualness is what makes it worse. There's another element that rarely gets discussed. Neptune's rotation. Despite being enormous, nearly 4 times Earth's diameter, Neptune rotates in about 16 hours. That rapid spin, combined with internal heat, contributes to the violent atmospheric dynamics. The planet is constantly in motion. Storms shear across latitudes. Wind bands wrap around its circumference. Supersonic gusts tear through cloud layers. It's not just cold and dark. It's active. Now zoom out for a second. Neptune sits at the edge of the solar system's main planetary region. Beyond it lies the Kuiper Belt, a vast region of icy bodies, dwarf planets, and debris. Neptune's gravity influences that region significantly. In fact, Pluto is locked in orbital resonance with Neptune. Neptune shapes the architecture of the outer solar system. It is not passive. It is gravitationally dominant in its region. And its presence may have scattered countless objects inward over billions of years. The blue abyss is not isolated. It's connected to a larger dynamic system. But perhaps the most unsettling part is psychological. Neptune is beautiful. Images from Voyager and Hubble show a deep cobalt sphere against black space, clean lines, symmetry, calm curvature. Nothing in those pictures suggests violence. And yet everything beneath that surface suggests instability. It's a reminder that distance hides complexity. Neptune doesn't roar like the sun. It doesn't glow like Jupiter's auroras. It doesn't display rings as dramatic as Saturn's. It sits quietly at the edge. But silence is not safety. And beauty is not peace. The terrifying truth about Neptune isn't that it's explosive. It's that it's unreachable, unstable, and inescapable. You cannot stand on it. You cannot swim in it. You cannot outrun its winds. And you cannot call for help in time. It's a planet that gives you no foothold, physically or metaphorically. If you try to explore it, You are committing to a descent into layers of pressure and fluid physics that humanity barely understands. And this is only the beginning. Because what lies even deeper inside Neptune, what truly drives its internal heat, what exotic states of matter exist there, is still largely theoretical. We have visited it once, for a few hours, in 1989. Everything else is inference. Models, equations, and educated guesses. Neptune is terrifying not because we've seen everything it can do, but because we haven't. And the deeper we model it, the stranger it becomes. And if falling into it is a one-way trip, we haven't even talked about the part where leaving becomes almost impossible. And if leaving becomes almost impossible, then Neptune stops being a destination and becomes a trap. Because here's the part that rarely makes it into documentaries. Even if you never attempted to descend into the atmosphere, even if you stayed safely in orbit, Neptune is still one of the hardest places in the solar system to escape from in any meaningful way. Not because its gravity is the strongest, but because of where it is. Neptune orbits the Sun at an average distance of about 30 astronomical units, roughly 4.5 billion kilometers. At that distance, sunlight is faint, communication is delayed by hours, and energy is scarce. Everything you do out there is constrained by physics and logistics. Fuel becomes precious, power becomes finite, time becomes enormous. To understand why that matters, think about velocity. Neptune's escape velocity, the speed required to break free from its gravity, is about 23.5 kilometers per second. That's comparable to Earth's escape velocity of 11.2 km/s, but remember, you're not launching from solid ground. You're surrounded by atmosphere and fluid layers. There is no runway, no launch pad, no stable surface. Any ascent would require enormous thrust just to maintain structural integrity, while climbing through violent winds and crushing pressure gradients. But suppose somehow a futuristic craft could hover deep within Neptune's upper atmosphere, study it, survive the supersonic winds, and then attempt to leave. It would still face another problem. Orbital mechanics at that distance are unforgiving. Neptune moves around the Sun at roughly 5.4 kilometers per second. Any mission there must match its orbital velocity. And once you're there, adjusting trajectory to return home requires precise burns and massive energy reserves. There is no gravity assist waiting conveniently nearby. Jupiter is billions of kilometers away, Saturn even farther. Every maneuver costs time and fuel. And time at Neptune's distance stretches into decades. Voyager 2 took 12 years to reach Neptune, and that was using gravitational assists from Jupiter and Saturn. A direct trip would have taken much longer. Modern propulsion systems are not dramatically faster unless you invoke advanced nuclear or theoretical drives. Which means if something goes wrong, mechanical failure, energy loss, hull damage, you are effectively stranded at the edge of the solar system. There's no quick correction. There's no second try. The phrase, "there's no escape," isn't just about gravity. It's about isolation amplified by distance. Now let's go back to the interior, because that's where Neptune becomes physically terrifying. As pressure increases toward the deeper layers, hydrogen and helium compress into dense fluids. Below that lies the mantle, composed largely of water, ammonia, and methane under extreme pressure. But under those pressures, water is not what we know. At millions of atmospheres of pressure and temperatures of thousands of degrees Celsius, water enters exotic states. One of the most fascinating is called superionic water. In this phase, oxygen atoms form a crystalline lattice, while hydrogen ions move freely through it, almost like an electrical conductor. It's neither a conventional solid nor liquid. It's something in between. Laboratory experiments on Earth have briefly created conditions that mimic this state, and models suggest that Neptune's interior may contain vast layers of it. Why does that matter? Because it changes everything about how the planet behaves magnetically and thermally. Neptune's magnetic field is not aligned neatly with its rotation axis like Earth's. It's tilted dramatically and offset from the center of the planet. That suggests the magnetic field isn't generated in a simple molten iron core like Earth's, but in these strange conductive fluid layers higher up in the mantle. In other words, Neptune's magnetic engine is unconventional, chaotic, dynamic, and a dynamic magnetic field means fluctuating radiation belts. If you were orbiting Neptune long-term, radiation exposure would vary unpredictably. Electronics would need heavy shielding. Human biology would struggle even more. Now let's address temperature again, because Neptune defies intuition. The upper atmosphere is brutally cold, yet deeper inside, temperatures may exceed 5,000 degrees Celsius. That internal heat source is one of Neptune's most fascinating traits. Unlike Uranus, which emits little excess heat, Neptune radiates about 2.6 times the energy it receives from the Sun. That means it's internally active. Scientists still debate exactly why Neptune is more internally energetic than Uranus, despite their similar sizes and composition. One theory suggests that Neptune's interior allows heat to escape more efficiently. Another proposes compositional differences or past impacts that altered internal structure. But here's the unsettling part. Neptune is still evolving. It's not a frozen leftover. It is thermally active, dynamically atmospheric, magnetically unstable, and gravitationally influential. And that combination makes it the opposite of peaceful. Now consider human survival in that environment. Even if you never descended, even if you remained in orbit in a station, you would face extreme constraints. Solar power would be nearly useless. You would rely entirely on nuclear energy. Maintenance cycles would be long and risky. Communication with Earth would involve a minimum 4-hour delay one way, up to 8 hours round trip. That delay changes psychology. You cannot have real-time support. You cannot troubleshoot collaboratively. You cannot react quickly to emergencies based on Earth's guidance. Everything becomes autonomous. Everything becomes irreversible. And in a crisis, that delay becomes existential. But perhaps the scariest aspect of Neptune isn't technological. It's conceptual. Neptune represents a boundary. Beyond it lies the Kuiper Belt, a vast region of icy bodies, dwarf planets, and debris. Neptune's gravity shapes that region. It shepherds objects. It locks some into resonances. It ejects others. It is a gatekeeper. And if you imagine humanity attempting to move outward into the outer solar system, Neptune is the last major planetary barrier. Crossing it means committing to deep space, beyond the comfortable gravitational infrastructure of the inner planets. And deep space is not forgiving. Neptune is beautiful because it hides this brutality behind color. Its deep blue hue suggests oceans, but there are no oceans to sail. Only layered atmospheres and fluid interiors that transition into crushing pressure. If you fell through Neptune's clouds, you would not hit water and float. You would accelerate, heat, compress, and eventually disintegrate as pressure exceeds the structural limits of any known material. There is no bottom you can stand on. There is no moment of impact, just gradual erasure. And unlike falling into a black hole, dramatic and final, Neptune's destruction would be slow and layered. Winds batter you first. Pressure compresses you next. Temperature rises. Molecules rearrange under force. Matter behaves differently. And eventually, the planet absorbs you into its interior, into a region humanity has never seen and may never directly observe. That's what makes Neptune terrifying. It doesn't explode. It doesn't scream. It doesn't burn like the sun. It absorbs, silently, and it does so billions of kilometers from any help. When we call it the blue abyss, that isn't poetic exaggeration. It is literally a bottomless descent into increasing density, increasing pressure, and increasingly alien physics. And maybe the deepest reason Neptune unsettles us is this. It looks calm. It looks smooth. It looks simple. But it is none of those things. It is a reminder that the outer solar system is not empty space with frozen decoration. It is active, dynamic, and indifferent, Neptune doesn't need monsters to be terrifying. It only needs physics. And physics at that distance and that scale is more than enough. Because once you commit to Neptune, there is no easy way back.